All right, let's look at some real-life scenarios where the distributive property can be used. Here's an example. Kyle buys 3 soft pretzels for X dollars each and 3 sodas for $1.29 each. Which algebraic expression represents the total amount he spent in this situation? Well, we have learned before that the word each is a word that very often means multiplication. And that's the idea that we're going to end up using here. The 3 soft pretzels are X dollars each, so we can take 3 times X. The 3 sodas are $1.29 each, so we can take 3 times $1.29. However, there is an alternate way of doing this. Since both the pretzels and the sodas, we're buying 3 of them for each, we can actually add the prices together first and then multiply that by 3. Do you see what I see? This is the idea of the distributive property, having a multiplier outside of the parentheses and addition on the inside. Speaking of which, that addition would come straight down. 3 times x is 3x. 3 times $1.29 is $3.87. Now, we don't know what x is. We can't go any further. But from here, we can see that choice C would have been the correct answer. Let's look at another example. Kayla earned $17 per hour. On Friday, she worked 6 hours. On Saturday, she worked N hours. Which expression represents the total amount of hours she worked? All right, kind of like the word each, we have the word per. And we've learned before that the word per, kind of like the word each, is the idea of multiplication. So $17 per hour means 17 times the hours. Well, on Friday, she worked 6 hours, so that's 17 times 6. On Saturday, she worked N hours, so that's 17 times N. But just like on the last problem, we could add the hours from Saturday and Friday together first, and then multiply that by 17. Once again, this is the idea of the distributive property with a multiplier on the outside and an addition on the inside. 17 times 6 is 102. 17 times N is 17N. Now, the order here is different, but we know from the commutative property that we could switch the order of the addition, and choice A is the same choice as what we got. Here's a slightly different example. Jerome buys 12 flowers, each for D dollars. However, he has a coupon that takes $2 off the price of each flower. Which expression represents the final price of the flowers he buys? Now, normally you would think that if he's buying $12 each for D dollars, that you would take 12 times D. But here's the deal. We saw that he has a $2 off coupon for each flower. That's $2 off the price of each flower. So we're not just taking 12 times D. We're going to have to take 12 times $2 off of D. Well, what is that mathematically? That's D minus 2. Now, if we knew what D was, this would be very simple subtraction. We could just subtract right away. But since we don't know what D was, we can actually still use the distributive property. Take the multiplier of 12, multiply it times D, but also multiply it times 2. Careful, we don't have addition in between this time. This time we have subtraction. Still the same idea. 12 times D is 12D. 12 times 2 is 24. And you can see choice D is the choice that makes sense for this problem.